Hello, I'm Stacey Jarlsberg, Product Manager for PCS 7 for the US market. And I'd like to spend some time this afternoon talking about ET200 SPHA and the MTA solutions that are available. Because ET200 SPHA sits on a PROFINET IO bus backbone, I do want to spend a few minutes talking about the value proposition associated with PROFINET, talk about ET200 SPHA, and then follow up with a discussion of the MTA solutions available. The PCS 7 controller, the AS410, does support a fully redundant PROFINET connection to ET200 SPHA. So when we talk about PROFINET, some of the value propositions associated with that include, the topology editor, which is built into PCS 7. So the topology editor gives us a graphical visualization of the PROFINET topology. In other words, it shows us the controller, it shows us all of the I/O, the devices that are connected to PROFINET. Now that's not just a static display. It's a runtime display. So because you can see in the slide, if there's an error that occurs, you're going to see red that shows up to be able to identify where in the architecture the error occurs. PROFINET also gives us the ability to automatically address all the devices that are connected to PROFINET. Well, what that means is I no longer need to set dip switches or go in and configure those individual interface modules one by one. Well, what does that really mean? Well, what that means is I no longer need to debug duplicate addresses while I'm during commissioning, shortening the commissioning time. When it comes to maintenance, PROFINET has this concept, I like to think of it as the neighborhood concept. In other words, every device is aware of the device before it and the device that's after it. Well, what that means is if an interface module were to fail in the middle of the night, you just go to the storeroom, pick up a replacement, install it, and then the system automatically assigns the correct address to it and automatically begins communicating back to the controller. What does that mean? Well, it means I no longer have to go find somebody who has access to the engineering station to be able to log in and download that information. Now, PROFINET also gives us a great functionality when it comes to scalability. For example, we can have a common I/O bus with multiple controllers. So depending upon a plant topology, depending on where the controllers are located, where all the cabinets for SPHA are located, I can actually have a common I/O bus and significantly reduce the infrastructure costs associated with the I/O bus. Now, talking about reduced commissioning costs, PRONETA. It's a free download. So, what is that? Well, it's a commissioning tool for PROFINET. In other words, I take my notebook computer. It doesn't need to have any PCS 7 software installed on it. I don't need a controller. I don't need the AS410 controller. I install PRONETA, and then I can connect to the PROFINET architecture and then communicate to the interface module. In other words, I can test the PROFINET cable, whether it's copper, fiber, the network switches in between, and I can make that communications. But there's more. I can actually loop check all of the I/O that's on that rail of I/O. In other words, many of you are beginning to do projects, we'll call them modular design skids. In other words, you go to multiple OEMs and they build a skid of equipment and they put ET200 SPHA I/O on there. And with PRONETA, it now allows the OEM to go in there and actually test that skid to ensure that all the analogs and the discretes are connected properly to the I/O. That way, that skid is fully functionally tested before it shows up on site for you to integrate into the DCS. Terminology is important. So when you look at the AS410, it actually has two port switches. We refer to them as the X5 and the X8. They're both fundamentally exactly the same. It just gives us two separate PROFINET accesses to the system. So terminology. We'll start with a single interface module on the ET200 SPHA, and we'll start with a single CPU or simplex controller. In that environment, we refer to that as an S1, no redundancy. So it's a single controller, a single interface module, and it's basically a single Ethernet cable that connects the two together. And you say, well, that's not very fault tolerant. Well, you're right. But we have the ability to use an MRP ring. I like to think of it as fault tolerant. Media redundancy protocol is the official name for it. And basically what it means is I can set up a ring between the controller and the I/O. So that's all good and well with regards to simplex controllers, but can we use a redundant controller? Yes. So we call that S2. So I still have a single interface module on my rail of ET200 SPHA, but now those two ports, one port goes to the left CPU, the other port goes to the right CPU. Fully functional, supports redundant controllers. You say, well, wait a minute, I want a fully redundant PROFINET topology. We can do that. We call that R1. So now on my rail of ET200 SPHA, instead of a single IM, we have two. So it's redundant IMs. So one IM gets connected to the left CPU, the right IM would get connected to the right CPU. Fully redundant PROFINET connection. Now when I look at ET200 SPHA itself, a lot of times we talk about availability, we talk about robustness. So if we talk about availability first, and I've already talked a little bit about PROFINET, from a redundancy perspective, we support the fully redundant R1, the S2, as well as an MRP ring for an S1 connection. But ET200 SPHA also supports fully redundant power supply connections, redundant I/O, and configuration and run. When we talk about robustness, the I/O is conformally coded out of the box. What does that mean? It gives us a temperature range of -40 to +70 when we mount the I/O horizontally. If I mount the I/O vertically, we can actually get to a +60 degrees C temperature spec. You say, vertically? Well, why would you do that? Aren't you limited to 6 or 8 or 12 I/O modules? No. Because of the design of PROFINET and ET200 SPHA, SPHA is very compact. The modules themselves are only 22.5 millimeters wide. We've got I/O modules that support 32 channels. And when it comes to the number of I/O modules on a rail, we can have 56 I/O modules on a rail of I/O. Allows us to build that vertical rail and change the way we think about building cabinets much more dense than we were able to do in the past. When it comes to installation, on the PROFINET side, we use standard RJ45, and we've got standard connectors for fiber connections as well. On the field wiring, we can take standard 14-gauge wire and connect that. Just push it in, it's connected. There's no screws, no torque testing. It won't work loose because of vibration. As an option, we have a D-sub terminal block that's also possible to use, and we'll talk a little bit more about that when we talk about MTA solutions. When we talk about maintenance, online module exchange is possible. We don't have to power down a rail of I/O and lose communications back to the controller. We can add I/O on the fly, so to speak. We don't have to power down the rail of I/O. We can add new I/O modules on the fly. We can do hardware configuration online. That's configuration and run. We can also do online firmware updates. Now, when it comes to the I/O, we've got a large family of I/O. So if we talk about digital inputs and outputs, we can support on the digital input the sequence of events with a 1 millisecond timestamp. We've got high voltage discrete in, discrete out, supporting up to 240 volts, 230 volts AC. We've got analog input, analog output, supporting HART, thermocouples, RTD. We've got fail-safe I/O that supports analog in, discrete out. We have intrinsically safe solutions that support analog in, analog out, discrete in, and discrete out, as well as not to be lost in all of the possible I/O modules, but we actually have a configurable I/O module that does analog in and analog out, voltage and current, does digital in, digital out, as well as frequency. So as I want to actually build now to talk about a little about MTAs, let's just sort of start talking about the AC input and output modules, because that's really where MTAs really shine, so to speak. So we've got an 8-channel discrete input module that supports 120 to 230 volts AC. And then we've got a standard relay output module to support outputs up to 240 volts, 230 volts. As an option to that, we can take the standard 32-channel discrete input card and marry that, connect that with the Phoenix MTA to support up to 240 volt AC on the inputs. We can take the 32-channel discrete output module, connect that to a Phoenix MTA, and drive up to 240 volt AC on the outputs. So how do we do that? Well, as I mentioned, so it's a D-sub. So when I build my rail of ET200 SPHA, instead of we'll call it the standard terminal block we've seen in the past, it's a D-sub. And then from that D-sub, I've got standard cables with connectors on both ends. I got flying lead cables, and that allows me to connect it to quote unquote MTAs or devices in the field that mirror your requirements for connecting to the field. As a specific example, we could take the D-sub terminal block, connect that with a Phoenix standard cable, and then connect that to a Phoenix terminal block or MTA. So in this case, we're going from an analog input, analog output, discrete in, discrete output module through the D-sub to a remote terminal block that's got screw terminals on it. On the AC side, I could take that same D-sub terminal block. I can use the 32-channel discrete input module. Now I use a different standard cable from Phoenix, and I can connect to blocks of relays that will support up to 240 volt AC on the inputs. If I use the 32-channel discrete output module, then I use the same cable, same terminal block, the D-sub, but I use a different set of relay modules from Phoenix to drive either solid-state relays or physical relays to get up to 10 amps on the outputs. As part of this presentation, the slide that you're looking at right now, there's embedded PDF files that have the details from Phoenix as to the cables and the relays associated with the solutions that I've just described. Thank you very much.